Okay, this is a lesson video for Geometry Unit 6, Lesson 1. And Unit 6 is assuming quite a bit of previous knowledge from the first half of geometry, and that's going to continue to be something that comes up. So there's a chance that you might struggle with some of the vocabulary, and you're going to need to maybe keep a notebook of terms with definitions if you're struggling to know those terms. Because I'm going to be assuming some of the same. I'm going to be talking about terms and talking about concepts that are covered in the first half of geometry. So you're going to need to do a little bit extra work if you're struggling to understand what those are, not understand, but remember what they are. So this unit is all about quadrilaterals. Quadrilaterals are, generally speaking, polygons that have four sides. So again, a polygon is just really a word that means a shape made of straight line segments. There are lots of different types of quadrilaterals. We are going to go through them basically one by one, learning the different kind of properties of those quadrilaterals. So the first lesson is going to be about parallelograms. So I'm going to jump over to another tab where I've got a little notes page that I will be able to share with you that shows kind of a summary of the 5 main properties of parallelograms that you need to know. So I'm going to kind of draw on here as we go along. So I'm just going to run through these 5 points and then we'll apply them down below in this diagram. So first of all, parallelograms, the very first thing is that they have 2 pairs of parallel sides. And that's kind of the defining feature of a parallelogram and where it gets its name. It has 2 pairs of parallel sides. If I'm looking at the diagram here, and we look this side here and this side here are parallel. And then this side here and this side here are parallel with each other. Parallel, of course, means that they don't intersect. They go at the same exact angle. And if I were to extend them, sorry about that, if I were to extend them, they would not ever intersect, even if I extended them out this way or out this way. Those lines are not going to intersect. I'm going to go ahead and clear that out. So that's the first main idea, is that the lines of the opposite sides of a parallelogram are parallel. Not only that, they're also congruent. So again, this side and this side are congruent to each other, and this side and this side are congruent to each other. And that's indicated in my diagram as these double marks and single marks. You can see that here and here. These symbols mean that those sides are congruent. So beyond that, there's actually quite a bit more that you can say. The next major concept is that if you look at the angles of a parallelogram, you also find a relationship that is congruent. So the opposite angles here are congruent and then these pairs of opposite angles in green are congruent. So we have 2 pairs of opposite angles that are congruent. Let's erase that. So that gets us our first 3 properties. The next one says that consecutive angles are supplementary. That's a very important term. I would say that's one of those major terms that you need to know in geometry. If there's like top 10 list of geometry terms, I'd say supplementary is definitely in there. Supplementary is the word we use when we have a pair of angles that add up to 180. So what we're talking about here is we're talking about this angle and this angle would be together adding up to 180. So when I add the green and the yellow, they equal 180 degrees. So you need to know that. So that's what it's talking about. And then there are, of course, other pairs. Obviously, this green one also would be, because the word consecutive means next to each other or one after the other. So each pair of consecutive angles, this pair, this pair, this pair, and this pair, are all going to be supplementary. So it applies to all 4 pairs along each side of that parallelogram. Lastly, we're going to jump down to the second diagram here and look at the diagonals. Diagonals refers to these lines that cross from one corner of a diagram of a shape to another. And so we see here that the diagonals bisect each other. Bisect means to, and cut, literally bi in Latin, and sect is cut. It means to be cut in two. So in other words, the diagonals cut each other into equal parts. So this diagonal in green comes and cuts this side into 2 equal parts. And then, of course, going the opposite direction, this diagonal cuts this into 2 equal parts. And so basically what we're going to be doing is we're going to be utilizing this information to solve some problems. So if you look down here at the bottom, I've got a diagram and I've got some questions. So we see we have a parallelogram here, A, B, C, D. And we know some things. We know that AD is 21. That's right here. We see that DC is 11. We see that the angle here in the corner for B, ABC, is 65. We also know that the diagonal AC is 18. And this portion of the diagonal here, DE, D to E, is 13. So what can we find out? And what we're going to do is we're going to walk through each question and say, which of these are we using when we do this? Which of these properties am I using? So let me just go ahead and I'm going to actually number these just so we can talk about them more easily. So looking at BC. So BC is right here. So the question is, what side has a relationship with BC? And so it should be clear that we're going to be looking at, sorry about that. We're going to be looking at this one right here. So if that one's 21 and we look at property number 2, I'm going to write that down. So using property number 2, we find that BC is also 21 centimeters. And we're using property number 2 because opposite sides are congruent. All right, let's look at the next one. AB. AB is this side right here. Well, that's corresponding with DC. And it looks like we're going to use the same property, property number 2. And property number 2 tells me that if this is 11, then the opposite side, AB, is also 11 centimeters. And this is what it looks like to use these properties. We're just taking what we know, seeing which property kind of applies to that situation, and then doing the math to get it. Angle C. Here's angle C right here. We know that angle B is 65. And we can see that these are not opposite angles because that would be like angle D and B. But now B and C are going to be consecutive angles. So if they're consecutive angles, that means that they have to be supplementary. So really quickly, all I have to do is do 180 minus 65 and get the answer that way. And I should get an answer of 115 degrees. And we're using property number 4. All right. So let's look at the next one. Angle D. Oh, now here we want to know about angle D. We like that because we already know that angle D, we just said it on the last problem. Angle D corresponds with angle B. They are opposite angles. And opposite angles are congruent.
That's what this symbol means. Congruent just means the same. So that means that D is 65 degrees, and that comes from property number 3. All right. Let's look at the next one. Next, we have EC. EC is this portion of the diagonal AC. It's just half of it. And that's kind of the key here. Because they bisect each other, I know that EC is half of AC. So if EC is what I'm looking for, and I know that AC is 18, then I just need to divide that by 2, and I get 9. EC is 9 centimeters, and that's coming from property number 5. Lastly, if we look at this last piece of information, we see that ED is 13, which means that the whole diagonal from B to D would need to be twice as much because it's the other way. Because I have the half, I need to do times 2 to find the whole thing. And so it would be 26 centimeters. And that would be property number 5.